We now discuss the solution of a problem from the section Permutations and Combinations, and the problem is on the number of non-negative integral solutions of an equation that arises in combinatorics. This question has appeared in the joint entrance examination main held on 27th June 2022 in the first shift. The given question is the number of ways 16 identical cubes, of which 11 are blue and the rest are red, can be placed in a row so that between any two red cubes there should be at least two blue cubes is. We are given 16 identical cubes and 11 of them are blue and the rest are red, and we want to find out the number of ways of this 16 identical cubes can be placed in a row such that between any two red cubes there should be at least two blue cubes. Such a kind of number of arrangements we have to find. Now, before discussing the solution of the problem, let us recall a result from the section Permutations and Combinations. We have studied the number of non-negative integral solutions of the equation x1 plus x2 plus so on and so forth plus xr is equal to n. We are finding the number of non-negative integral solutions of this equation. This is same as the finding the number of ways in which n identical balls can be distributed into R boxes where one or more box can be empty. The above, that is the number of non-negative integral solutions of this equation, is the same as finding the number of ways in which n identical balls can be distributed in R boxes where one or more can be empty, and that number is n plus r minus 1 c r minus 1. The so many combinations is the answer. So remember this, we will be using this result. That's our given question. Agreed. We now discuss the solution of the problem in detail. We are given 16 identical cubes, of which 11 are blue and 5 are red. What is our task? Our task is to find the number of ways of placing 11 blue and 5 red cubes in a row such that at least two cubes are to be placed between any two red cubes. At least two blue cubes are to be placed between any two red cubes. Now let's see the demonstration. We first arrange the 5 red cubes in a row. So that is the first red cube, second, third, fourth and fifth. So we have arranged the 5 red cubes in a row. So between R1 and R2, blue cubes are to be inserted, but the number of blue cubes should be greater than or equal to 2. let Bi, that is B1, B2, B3, B6, be the number of blue balls, number of blue cubes, to be arranged as shown: B1, B2, B3, B4, B5, B6. We are given a condition on B2, B3, B4, B5 only. That is, between any two red balls, at least two blue balls are to be inserted. That means B2 must be greater than or equal to 2, B3 must be greater than or equal to 2, B4 greater than or equal to 2, B5 greater than or equal to 2. We see B1 and B6. B1 is before R1, B6 is after R5. And no conditions are laid down on B1 and B6. Therefore, B1 is greater than or equal to 0 and B6 is greater than or equal to 0. We are given that at least two blue cubes are to be placed between any two red cubes. Therefore, B2 greater than or equal to, B3 greater than or equal to 2, B4 greater than or equal to 2, B5 greater than or equal to 2. And on B1, B6, no conditions are there. B1, comma B6 is greater than or equal to 0. Now, how many blue cubes we have? We have 11 blue cubes. Therefore, if you add B1, B2, B3, B4, B5, B6, it should be 11. Since we have 11 blue cubes, B1 plus B2 plus B3 plus B4 plus B5 plus B6 is equal to 11. Let's call this as the equation 1. We continue in the next slide. So that is what we have. We also have, we have seen just now, B1 plus B2 plus B3 plus B4 plus B5 plus B6 is equal to 11. That's the equation 1. With the constraints Bi greater than or equal to 2, for I is equal to 2, 3, 4, 5, and B1, B6, B1 is greater than or equal to 0, B6 is greater than or equal to 0. Now, let B1 is equal to, capital B1 is equal to B1, small b1, Bi is equal to small bi minus 2. Capital Bi is equal to small bi minus 2. For I is equal to 2, 3, 4, 5. Capital B6 is same as small b6. Now, Bi for I is equal to 2, 3, 4, 5. It is greater than or equal to 2. Therefore, Bi minus 2, that is capital Bi, is greater than or equal to 0. And anyway, small b1, small b6 greater than or equal to 0. Therefore, capital B1 and capital B6 is greater than or equal to 0. Thus, we note down that this capital Bi greater than or equal to 0 for all I is equal to 1 to 6. And the above equation 11 now becomes, for B1, capital B1, for B2, it is capital B2 plus 2. For B3, capital B3 plus 2 plus capital B4 plus 2 plus capital B5 plus 2 plus B6, capital B6 is equal to 11. Now see, how many 2's are there? 2 plus 2 plus 2 plus 2, 4 2's are 8. That 8 push into the other side, then you will get 11 minus 8, that is equal to 3. Then we get B1, capital B1 plus capital B2, B3 plus B4 plus B5 plus B6 is equal to 3, where each Bi greater than or equal to 0, non-negative, for all I is equal to 1 to 6, non-negative, positive, non-negative integers. So that's that the number of ways to do the task, that our original task, is now reduced to this mathematical equation. It is same as the number of non-negative integral solutions, because now B1, B2, B3, B4, B5, B6 are non-negative integral solutions, such that their sum is 3. Such that this is the equation B1 plus B2 plus B3 plus B4 plus B5 plus B6 is equal to 3. All B's are in capitals. Now, let's recall our result. The number of non-negative integral solutions, these are non-negative integral solutions you have to find. For this equation, x1 plus x2 plus etc. plus xr is equal to n. is given to be n plus r minus 1 cr minus 1. In our case, n is 3 and r is 6. Therefore, the answer to this question is n plus r minus 1 into cr minus 1. That is 3 plus 6 minus 1 c 6 minus 1. That is 9 minus 1 8 c5. 8 c5 is same as 8 c3. Yes, ncr is equal to ncn minus r. And 8 c3 is equal to 8 into 7 into 6 by 1 into 2 into 3. Simplify, you will get 8 sevens are 56. That's our answer. So, our answer is the number of ways of placing 11 blue and 5 red cubes in a row such that at least 2 blue cubes are to be placed between any 2 red cubes is 56. So, that is the answer to this question. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.